I spent 14 years in nuclear power. When you work in an industry where getting it wrong means catastrophe, you learn something most people skip. Capability without control isn't progress, it's risk. AI is moving faster than anything I've seen. The question isn't whether it's powerful, it's whether we're building the systems to handle what comes next. I've worked in nuclear and aviation. This feels familiar. Here's the question most people miss. What does a nuclear reactor have in common with GPT-4? On the surface, nothing. One splits atoms, the other predicts text. One weighs thousands of tons, the other lives in a data center. But I've worked in both worlds. And when you've spent years managing systems with massive raw power, you start seeing the pattern. The engineering challenge is identical. Unprecedented capability with consequences you can't fully predict. The first thing you learn in nuclear? Unlearning the movie version. I spent 14 years in that industry. Everyone who walks in carries the same mental model. Commercial reactors are bombs waiting to go off. Homer Simpson, action movies, mushroom clouds. Wrong. Commercial fuel is low-enriched uranium. You physically cannot make it detonate like a weapon. The physics don't allow it. Yes, accidents can happen, severe ones. But the core image in your head, the one you've had since childhood, is fiction. Here's why that matters. We're doing the exact same thing with AI right now. We're walking in with a mental model borrowed from science fiction, and it's just as wrong. Here's what 14 years in nuclear taught me. The difference between disaster and triumph isn't the power, it's the harnessing. A reactor core and a frontier AI model have the same problem. Immense capability, unpredictable consequences. The raw force isn't the product, it's just the starting material. The real engineering is what happens next. How you capture it, direct it, and build the systems that keep it useful instead of dangerous. That's the part most people skip. So what does harnessing actually mean? Not the corporate version, the engineering version. A nuclear plant isn't just a giant boiler, it's layer upon layer of precision. Control rods dropping into the core to absorb neutrons. Soluble boron in the coolant. Water chemistry managed to the molecule. Massive redundant cooling loops. Those iconic containment structures. It's a stunning amount of effort. All of it focused on one goal, directing power safely. After 14 years, I stopped seeing a bomb waiting to happen. I saw what it actually was, an engineering triumph. That's what harnessing looks like, and that's what we're not building for AI. But we didn't start with those engineering triumphs. We started with catastrophe. The early days of nuclear were reckless in ways that sound like fiction. Scientists manipulated plutonium cores by hand, sometimes with a screwdriver as a spacer. The radium girls were told to lick their paintbrushes for a finer point while painting glow-in-the-dark watch dials. At early bomb tests, personnel were just told to watch the flash. No protective gear, no dosimetry, no understanding of latent damage. The human cost was severe. Radiation sickness, fatal accidents, lifelong consequences. They had unprecedented power. They had no idea how to handle it safely. The harness didn't come first, the disasters did. Those disasters forced an evolution. Today, the nuclear industry is one of the most tightly controlled, rigorously engineered sectors on the planet. That shift didn't come from fear of the power, it came from respect for it. They learned that if you want the benefit, you can't cut corners on containment. You build the harness first, or you don't build at all. The protocols now are obsessive. The safety margins are extreme, because they had to be. Here's the pattern. Capability without structure isn't innovation. It's just expensive chaos waiting to happen. Here's the uncomfortable part. Most people think they understand how AI works. They don't. A 2025 survey found 45% of people believe ChatGPT is basically a sophisticated search engine, looking up factual answers in some giant database. Only 28% understand it's actually generating text by predicting what words come next based on learned patterns. That's not a small gap. That's the difference between a calculator and a simulator. People are treating a predictive text engine like it's a verified encyclopedia of absolute truth, which means they have no idea what they're actually asking it to do, or what it can't. So why does that gap matter? In nuclear, a bad mental model led to real radiation sickness. People died because they didn't understand what they were handling. In AI, the cost is different, but it's just as real. Systems hallucinate with absolute confidence. Sensitive corporate data leaks because someone pasted it into an open prompt. Leaders mistake predictive text for verified truth and make terrible decisions based on it. We're licking the radium paintbrush again, just with a cleaner interface. The technology hasn't changed. The misunderstanding is identical. I've worked with enterprise systems long enough to recognize a useful mental model when I see one. Think of a frontier AI model like a brilliant graduate from a top university. Highly capable, strong reasoning, can synthesize information and solve complex problems. But would you hand them your entire operation on day one? Of course not. They lack context. They don't know the unwritten rules. They don't know which problems actually matter. They have zero organizational memory. To make that graduate useful, you build structure around them. Mentorship, feedback loops, clear responsibilities, boundaries. AI needs exactly the same thing. The capability is there. The harness isn't. Here's what most people get wrong about AI safety. They think guardrails mean making the system weaker. I spent 14 years in nuclear. Control rods don't make a reactor weak. They make it controllable. Containment doesn't reduce output. It makes that output safe for the city next door. Harnessing isn't about limiting power. It's about making power reliably useful. The difference matters. One is fear, the other is engineering. Right now, we're building AI systems with all capability and no harness. That's not innovation. That's just expensive chaos with a nice interface. Building the harness. 4 steps. AI systems need. So how do you actually build the harness? 4 structural steps, not suggestions, requirements. 1. Curate verified context. Feed the model from known validated sources. Don't let it freestyle from training data that might be 3 years old or completely fabricated. 2. Build hallucination detection. Automated systems that catch confident lies before they reach a customer or a boardroom. Because they will lie, and they'll sound certain doing it. 3. Tool use with strict permissions. If an AI can send emails or touch files, it needs hard boundaries, not guidelines. Boundaries. 4. Embed human oversight structurally, not as an afterthought, not as a checkbox, as a required step in the workflow itself. This isn't about slowing AI down. It's about making it safe enough to run at full speed. This isn't philosophy. It's being built right now. Take the Model Context Protocol, MCP, introduced by Anthropic in late 2024. Massive adoption throughout 2025. It's a standardized protocol designed specifically for safely connecting AI models to external tools and corporate data. This is engineers building the literal containment structures for AI, the control rods, the harness. It's moving us from raw, unharnessed text generation, where the model just predicts whatever comes next, into controlled, safe utility. The architecture is being laid. The question is whether your organization is paying attention or still treating this like a chatbot experiment. Here's the overarching point. There are 2 parallel tracks running right now. One is the race to build smarter, larger, more capable foundation models. That's a worthy pursuit. The raw intelligence we're seeing is extraordinary. But the other track, building sophisticated harnessing system, deserves equal attention. Maybe more. The intelligence bottleneck has largely been solved. The models are extraordinarily capable right now. The actual bottleneck we face today is the harnessing, which brings us to the final question. Are you chasing raw power or are you building the harness? I've seen this pattern before. In nuclear, we learned the hard way. Capability without containment isn't an asset. It's a liability waiting to materialize. The models are already smart enough. The question now is whether you're treating this like a chatbot experiment or whether you're building the architecture that makes intelligence safe to run at scale. The harness deserves equal attention, maybe more. Thanks for watching. Follow for more.